Hello students. In this class we shall study about ideal gas laws, and these are the laws. First comes Boyle's law, then comes Charles' law, and then comes Avogadro law. And by combining these three laws we get ideal gas law. Now before we come on to Boyle's law, we have some assumptions of ideal gas. What are these assumptions? First is that the molecules are dimensionless. And they are only point masses. Point mass. Molecules are only point mass. And second is molecules move in random direction. So in ideal gas, the molecules are moving in random direction. This is a container, gas container, and it is fitted with one piston, movable piston, and it has got some pressure P, volume, and temperature. And let us suppose there are n mole of gas. N is the number of moles of the gas. So in this diagram, the molecules are moving in random direction and they collide with each other. The molecules collide with each other elastically. Elastically means there is no loss or gain of energy. This is elastic collisions. And fourth is there is no electrical force between, no force of attraction or repulsion between the molecules. And fifth assumption is that pressure is created by the collision of molecules with the walls of the container. So these are some of the assumptions with our ideal gas model of the gas. But in the real gas, these assumptions are not applied, and hence real gas is different from ideal gas behavior. Now these laws are only applicable in ideal gas, and a real gas at very high temperature and very low pressure, it behaves as nearly ideal gas. So now we take the laws one by one. First we take Boyle law, Boyle's law. See, there are four parameters: volume, pressure, temperature, and number of moles. In Boyle's law, this is the relation between volume and pressure. Volume is inversely proportional to pressure. This is called Boyle's law. And constant number of moles and temperature is kept constant. This is called Boyle's law. Volume of a gas is inversely proportional to pressure. How? Let us take this example. If we apply some pressure on it, this piston will move here and the volume of gas will decrease. If P is increasing, then volume will decrease. This much of volume will be there after applying the pressure. So Boyle's law says that volume of a gas is inversely proportional to the pressure of the gas. Second comes Charles' law. Charles' law, volume is directly proportional to temperature, and here pressure and number of moles, that is kept constant. And see, if temperature is increased, then keeping pressure and number of moles constant, then volume will also increase, because increasing the temperature will increase the kinetic energy of the molecules and they will expand to increase the volume. Now third is Avogadro law. This is volume is directly proportional to number of moles, keeping pressure and temperature as constant. So if we combine all these three, number 1, number 2, number 3, then we get that V is equal to V is directly proportional to NT by P. Or in other words, we can say that PV is directly proportional to NT. And now this can be replaced by this by putting a constant. This is constant of proportionality. Constant of proportionality, and this is called gas constant. Molar gas constant PV is equal to nRT. This is ideal gas law. PV is equal to nRT, and R is the ideal gas constant, that is its value is 8.3145 joules per Kelvin per mole. This is the value of ideal gas constant. Now let us see what does this PV is equal to nRT, PV has another significance. This is the work done by the system. When temperature or number of moles are changed and pressure or volume is changed, any of the parameter is changed, then some work is done by the system, and this work done is represented by P into V. How? Let us see. This is the system of gas. This is piston here, and here are molecules in this system. Now if we give heat to this system, what will happen? This gas will expand and volume will increase, temperature will increase, then the piston will reach here and the volume will increase to this. So the system will do some work on this piston, and piston will move by this distance, let us say it d. So pressure is, what is pressure? We have studied in our earlier classes that pressure is force per unit area. And what is volume? PV, force divided by area into volume. Volume is area into distance. So A cancels out with A, and we are left with PV is equal to F into force into distance. And force into distance, we have studied in our earlier classes that it is the work done. So the significance of PV is equal to the work done by the system when any of the parameter is changed. Now we come on to the Avogadro number. One concept of